Good morning everyone. Thank you for coming to today's webinar on wheat powdery mildew, which Jeff Thomas will be discussing with you. Thank you, Jeff.
Thank you, Dominic. Welcome everybody. We're going to briefly spend some time talking about wheat powdery mildew, which is obviously a disease of note at the moment, particularly in the northern ag region. I guess wheat powdery mildew is an interesting one that it waxes and wanes depending on the varieties that are in vogue through a series of seasons, and obviously then the seasonal conditions. We're going to briefly just go through the pathogen, some of the factors influencing its survival, and then look at a bit on varieties, and obviously the thing that most people seem to be interested in, which is fungicide management. I'll start out by telling you what I'm going to tell you. Powdery mildew, as we know, produces masses of spores, spreads on the wind, and has a pretty short latent period. That's spore to infection to sporulation. So it really can develop rapidly in a crop and move through a crop or a region pretty quickly. A high proportion of the popular varieties that we grow at the moment are moderately susceptible or worse. So a high proportion of our crop is at risk. Humid, mild weather and thick, lush, damp canopies sort of favour the disease. Fungicides definitely can reduce disease severity, but what we've seen is that yield responses certainly occur, but they can be variable from around no response to around a 15% response to a single spray. Where the disease is present and increasing in the crop canopy and weather conditions are favourable, need to think about intervening in susceptible varieties to stop disease reaching damaging levels and moving up into the flag and up into the head. Certainly if we look at this leaf here, a flag leaf, allowing the disease to reach that sort of level on a flag leaf puts extreme pressure on fungicides in terms of controlling the disease, in terms of potential for fungicide resistance developing, and obviously already that leaf has lost more than 50% of its leaf area, so that's going to be having a significant impact on yield in that crop. Very briefly, a little bit on the actual fungus, Bloomeria graminis, form specialis tritici. It's the same family as the barley powdery mildew, but is host specific to wheat. So a lot of the things that we know about management of mildew or understanding the disease of mildew disease in barley can be transferred in some way into wheat, but remembering that the wheat mildew is wheat mildew. We see symptoms pretty much on all the above ground portions of the plant. Typically what we see is these white pustules which appear on those plant parts, and they produce masses of spores with a powdery appearance. And if you have a look at this picture on the right here, these footballs, each one of these footballs is a spore, and basically that pustule just produces long chains of these footballs which snap off and blow around. And we're talking millions and millions and billions of spores being produced within a crop canopy. As those lesions age, we produce these. The fungus produces these black fruiting bodies called cleistothecia in the older pustules, and they are part of the longer-term survival capacity of the fungus. And we don't know a lot about the virulence in the powdery mildew population in WA. Powdery mildews are very variable, but we expect that given the wide spread, that generally speaking the responses will be similar, but there may be some differences regionally or paddock to paddock in the virulence of the fungus. So very quickly onto the life cycle of the disease, and as I said, we know a lot of this about this from barley, but just for the purposes of understanding, if we start at the beginning of this year, what we've got is survival of the powdery mildew fungus as those cleistothecia in crop debris, or in green material as conidia on the leaves surviving through the summer. Those cleistothecia produce ascospores which infect any green material available, develops mycelium on the young plant, releases those little footballs we were talking about, and then we get the infection cycle occurring within the crop canopy and then between crops. Then towards the end of the year, obviously, we get the Cleistothecia being formed on the old leaf material and trash, and so the process continues. A couple of points that I guess just around that life cycle. As we said, the spores are produced on crops and volunteers, millions of them, and so they are spread rapidly and widely. And interestingly, if we think about some work done by the Curtin University on barley powdery mildew with their schools program, where schools are growing pots of susceptible barley across the state, you can pretty much get barley mildew everywhere. So there's certainly a level of spores pretty well distributed across the wheat belt. The mildew is favoured by sort of mild temperatures, sort of 15 to 20 degrees, 22 degrees, with periods of high humidity, and that's what the mildew likes. And really what we're talking about there is WA winter temperatures, particularly in say the northern wheat belt. It doesn't need free moisture, so that's water on the leaf surface for germination, spores to germinate. In fact, free water lying on the surfaces can actually inhibit spore germination. What that really means is, though, it doesn't need rain for the disease to spread. So whilst rain provides the opportunity for canopy humidity to occur in days following rain, the rain itself is not necessarily going to spread the disease, and sometimes can even put a bit of a hold on it as it washes some of those spores off leaves. As I said, it's got a rapid life cycle. New pustules are produced in about a week, anywhere between sort of 4 to 5 days through to 14 days depending on temperature. So definitely the disease can take off in a hurry. And temperatures over about 25 can inhibit disease development. So what we've seen often in the northern region or eastern regions is that 2 or 3 days of warm northerlies or easterlies can actually just stop the disease in its tracks. And certainly if we had a week like the early August last year in the northern wheat belt, then a lot of this mildew would disappear overnight. Just quickly on symptoms, those, as we said, that powdery appearance is what we're looking for. I guess the interesting thing in wheat is often what we can see is actually the powdery mildew at the base of the canopy, maybe on stems. So yes, this is the bottom stems, and often that's the indicator that there's mildew in the canopy. And then that obviously those spores are produced, and that can rapidly move up through the canopy until we end up with disease up into the flag leaf, for example. And then obviously the most impressive thing that we see with mildew often is the heads getting invaded and these spores being produced up on the awns and glooms, and that's certainly something that we would like to avoid by getting in and controlling the disease before that occurs. This picture on the left here is obviously an old leaf, and what we can see there is the yellowing of the leaf as the mildew hastens senescence of the leaf. But interestingly, you can see that over time those mildew pustules become a sort of a pinky browny colour, and then you get these little peppercorns in there. Poppy seeds in there that are the Cleistothecia that we're talking about as the longer term survival structures. All right, that's really some of the information about the fungus itself. I guess a lot of interest at the moment is around controlling the disease with fungicides. As you can see from this table, and these are trials that have been run in the past by people like Keith Jayasena in Albany and Rob Lockman and some of our landmark colleagues. These results are from trials run in the late 90s and early 2000s. We don't personally have any newer information for wheat mildew in Dafwa, but I guess the interesting thing about this is this coincides with varieties such as Brookton and Cunderdin, which were susceptible to the disease and certainly were part of that development of powdery mildew as a disease in wheat at that time. I'm not going to go through each of these trials, but what I'd like to point out is that in 3 of the 6 trials we got a significant yield response. So in 3 of the 6 trials we didn't get a significant yield response. And that yield responses to a single spray sort of range between that less than 10%, that 4 to 5%, through to about a 15 to 17% yield response, which equates to about a 100 to 300 kilo yield response in these 2 to 3 tonne crops. What I'd just like to point out is that in situations where the disease has maybe continued on and we've had multiple sprays, there has actually been a subsequent increase in response, and so here we've seen with a double spray or a triple spray that we've actually increased our yield response, and in this trial here, I haven't shown the data, but where there was a double spray there was actually about a 20% yield response. So we're in situations where the disease perpetuates, maybe starts early and perpetuates, then we do see can see a response to more than one spray, and you can see that in both of these cases the first spray went on at stem extension. Just briefly on that, what we know is that we can see a significant reduction in disease severity with these fungicide applications. In all of those cases, disease was reduced by application of fungicide. But that doesn't mean that we're going to guarantee a significant yield response. In those trials, from a single spray, responses varied from less than 5% through to sort of 15 to 17%, as I said, under 100 kilos up to about 300 kilos. I guess the interesting points are that a range of registered products gave a response. And so in those trials we were looking at some older products, and certainly we had Triad in there. What we would expect that newer registered products would be doing a similar job or even better, and it's probably reasonable to expect that fungicides that are providing the best response in barley mildew are going to give the similar sort of response in wheat mildew. And I would suggest that the sprays that we're applying regularly for yellow spot or Staganospora nodorum control in wheat at flagleaf are going to give a significant control of a powdery mildew. I guess a couple of points that we need to make are that in some trials that I haven't shown, the greatest responses to fungicide actually occurred when mildew was present with other diseases, and particularly in those early 2000s trials that run by Jat Batal in the north, when there was leaf rust present. But if we've got a level of yellow spot or Staganospora present in the crop, then the combined response is probably going to be greater than that we've seen here. And certainly something from the northern areas that I've had questions about is the differences in sowing time or crop maturity right at the moment. So early sown crops which reach flag leaf and heading earlier in the season are probably at the greatest risk. They've been exposed to the disease for a longer period. The disease has had time to build up for a longer period in the crop at the moment, and that important flag -1, flag leaf and head is being exposed to favourable disease conditions for longer. And in fact, this is not just a mildew story, this is a Staganospora nodorum story, say in your mace or your wild catchum, that those diseases, the top half of the plant is actually being exposed to the disease favourable conditions for longer period. And so in fact there may be some benefits in terms of managing disease slightly later, more like it may be a slightly longer season environment for those crops. I'm not going to spend a long time on fungicide resistance. I'm not aware of any evidence that powdery mildew exhibits any fungicide resistance in Western Australia, but I did want to make the warning that we know that barley powdery mildew has resistance to some DMI fungicides, and that is almost certainly as a result of our use pattern of fungicides trying to manage mildew in the southern regions of Western Australia particularly. Currently not the case for wheat powdery mildew, but it is an absolute warning for us of what can happen, and so we really need to follow good resistance management strategies. Try to avoid repeated regular applications of a single active and where possible even a single fungicide group. But please, a warning that the barley mildew situation is a warning to us about what might or could possibly happen with wheat mildew. varieties. This is out of the wheat variety guide, the DAFFA wheat variety guide. And if you have a look at the table here, you can see that there's a lot more varieties in that moderately susceptible to susceptible through to very susceptible side of the draw than there is in the MS through to MR side of the draw. And certainly varieties such as Calingary, which we've been having reports about, Mace, which is obviously the majority of the crop area, Wildcatchem, and Korak, which is particularly bad in this situation, are in the susceptible end of the scale, and therefore what we know from both our screening trials but also from our experience with barley is that those varieties are the ones in which the mildew certainly can take hold very quickly, and they're the ones that we need to be keeping the greatest eye on and being prepared to act if the disease is reaching some damaging levels. Just a point for you, DAFFA every year as part of the MVT disease screening activities screens all of our current and emerging varieties for their resistance rankings to powdery mildew, and as part of that we utilise it's actually carried out by Manisha Shankar's group and here in DAFFA, utilise isolates from across the wheat belt. So these rankings represent the worst case scenario in terms of the virulence present in the wheat belt for powdery mildew. So in summary, where are we at? We should be monitoring susceptible varieties. Now obviously there are a lot of people out doing that at the moment, but particularly in early sown crops where the disease has had a chance to develop throughout the season, which are probably heading towards flag or even heads out, and so that's being exposed to favourable conditions at the moment. Dense canopies, as we've talked about, where the moisture and humidity within the canopy is held there, higher humidity in dense canopies. High nitrogen status, there's certainly a link between high nitrogen status and mildew development, both in terms of lush plants and in terms of canopy humidity. And a good soil moisture profile. So the rain, as I talked about, rain is not necessarily spreading the disease, but it can often end up with, what we end up with is good levels of soil moisture, and we know that those canopies have a higher humidity as a result of that soil moisture. So maybe heavier soil types, lower in the profile, the sort of areas where we might see mildew developing first. Common message: fungicides are more efficient as protectants than eradicants. So I'm not saying that we should apply before disease appears, but I'm certainly saying that we should apply before the disease becomes severe. And the period of time that you have for that to occur is dependent on the environment at the moment, but also on the variety that you're growing. So if you've got a crop that's MSS or lower, so Mace, Wildcatchem, Korak, Trojan, I've put here before infection reaches 5% infection. What I'm talking about there is, if it's about 5% of the leaf area in the canopy, it's a rough estimate, but basically if there's about 5% of the leaf area in the canopy that looks affected, that's probably a good warning that it might be time to think about acting, particularly in those VS and S types. And if it's starting to develop up the canopy, then certainly that's an indication that it's worth thinking about providing some protection. And also before the canopy becomes too thick or we're starting to lose flag leaf area, certainly is a time to think about acting. I did want to make the point though that weather conditions can strongly influence disease development. So warm, drying conditions in spring can limit disease development and actually reduce the need for fungicide, or can also reduce the response to fungicide. So a couple of weeks of dry weather with drying easterlies act almost as a fungicide, and we know that. So in mildew, that is a similar response to other diseases. I'd just like to say that a lot of this acknowledged the work by Kith Jayasena, Jat Patel, Rob Lockman, John Majewski, Kazui Tanaka, Kira Beard, and Landmark for the trial results, and to GRDC and Domini's PhD program for the assistance in running these webinar series that we have going on, and there are several of them that have occurred. Thank you.
Okay, thank you, Jeff.